All right, welcome to this, the second episode in this series where we're going to be building an NES game live on stream, and I'm going to do a slight recap from the first episode because the first episode had an issue where, oh, thanks Java, that's exactly what I needed right now as an update. I'm going to recap from the first episode because the audio in the first episode was a little garbled because of, I broke the old adage. You know, when you're demoing software, they always say don't change anything right before the demo. Just stick with what you've got, or don't add anything new to the demo. Like try to demo something that you haven't ever you didn't prepare for, that you didn't actually try to demo before the demo itself. And I broke that rule by trying to watch the stream on a different system other than the machine I'm streaming on, and it was causing the audio to feed back into the loop. And so the entire intro to the stream was just a jumbled mess of Geico commercials and stuff like that. So sorry about that. So to reintroduce, I'm going to be doing a series of streams where we write a game for the NES. We're going to start out with this shooter and then progress to maybe something a little more complex and interesting. This is really just sort of the beginning stages of it because, excuse me, I am also still learning. I am not an expert when it comes to the NES, and we will see that many, many times as we go through this and the other project. However, I have been programming professionally for almost 20 years. I have a lot of experience writing code, and specifically writing C and C++ code and other code over the years. And so I feel confident that, you know, my experience and my knowledge there will lend itself to learning how to program for this system, and we'll hopefully build something really cool and learn some stuff along the way. And yeah, so let's get started. So the last stream we were talking about the architecture of the NES and how it works. You had the very briefly, you had the input side and the output side, and we talked about memory mapping, and we talked about the different components, the CPU, the APU, and the PPU, and how that how they all work together to form the game. And then I have this game here. This is a simple shoot 'em up type game. So if we go to this, I have Sublime Text set up to build this with a make file. We just take a look at this make file. It's just calling the assembler to generate the object file, and then it's linking it and creating the NES ROM. So here is the NES game. Once again, I don't have the Bluetooth controller set up here, so let's get that going. All right, that's connected in. And let's run that again. Okay, and then so this is the basic functionality. This is what we showed last time. Very straightforward so far. But what I was talking about last time is the fact that right now I'm doing basically all of the work in my VBLANK section of the code, and realistically I don't want that. I want it split up between the VBLANK and the main portion of the code up here that gets called from when the reset occurs, from when the NES powers up for the first time and it jumps to this reset location, or if you hit the reset button and it starts over and it reinitializes everything for the game to start over. So right now it's just hitting this point where it's looping forever, and nothing happens until VBLANK occurs. So you can see I added this to do here. So let's actually do that today on the stream. And it's going to be a shorter stream just because of how late it is for me and how long the stream went last time. But we'll see. We'll see how that actually ends up. If that ends up being shorter, or if it actually ends up being same length. I tend to be a little verbose in my explanations and when I'm talking. So. Tends to make things drag out a little bit. So yeah, so let's start out with how we're going to separate this out. So right now in the beginning of this, we have the code that's going to populate the OEM. The OEM is essentially the sprites. It's object attribute memory. So it's the hardware sprites on the NES, and we're copying from our sprite memory locations. Basically we've got, the way that it works is we've got an area in memory, and I'll show you this. There's an area in memory where we're drawing all of our sprites. So if this is our memory here, right, this is our 2K, somewhere in here we've got a chunk of memory, and I'll show you what that range is. And that memory is actually our sprites, right? That's the representation of what we want the hardware sprites to do. But then the PPU separately has some memory inside of it that is for sprites, right? And so we need to copy the data for the sprites from the main memory into the PPU. We don't have direct access to this memory because it's within the PPU. And we also have to refresh it every time, because the way that the hardware works on the NES, unlike what we would traditionally think of as RAM on a normal system where you can write it and it stays pretty much the same until you overwrite the values, it is actually a type of dynamic RAM that once it's been written, after a short period of time, the values in here apparently will decay, meaning that they do not hold their state. So every time we want to update the sprites, we have to rewrite this, or I should say, every time we want to display the sprites, we have to rewrite the values from our memory into the sprite memory of the PPU, which is different than on the Game Boy Advance, where that memory, as I recall anyway, was pretty much steady state. You know, so you wrote a value in it, it didn't decay, it didn't disappear, it didn't get corrupted. It would stay pretty much the same way it was when you wrote to it until you wrote to it again. So every time we go through this VBLANK loop, we have to update the memory in the PPU. So our sprite memory starts at this 200 range here, the 0200 range in the memory address range that we're clearing out. And you can see that we're clearing it out with the value of 255 instead of 0, like the other memory ranges that we're clearing out. And the reason is because we don't want the sprites to appear on screen unless they're actually being used by something that's alive in the game. So what we're doing in here is we are essentially looping through the entities that we have in memory, which are kept at that entity range of memory that we've reserved. So if you look at this entities, if you recall, this is the size of a single entity times the maximum entities. We're allocating that space for up to 10 entities right now. That may change later on down the road in terms of how we want that to be represented, but for now that's what it is. So we're going through and we're looping through all of the entities to find the ones that have a state or a type that isn't none or no entity, right? Which is type 0. So if it's a player type, it's going to go to the part of the code where it's building the player sprite, which is actually 4 separate sprites. And if it is a bullet, it's going to go to the code that actually sets up a bullet sprite, and that will be done right here. And then if that's it, then it's going to just loop through and see if the next entity in memory needs to be drawn. So here's the code for the bullet. It's really simple. It's basically just taking the X and Y and storing it into the sprite memory offset by the Y. So let's talk about this for a second here. This store with the parentheses around the sprite mem. So sprite mem is a 2-byte address that we're writing the location in memory of our sprite map. So if you go back to here, we talked about how we're going to have the sprites stored in the system memory and copied over to the PPU memory. So why is this not doing what it's supposed to do? So what I was saying was that we have, if you look here, what we're doing is we're doing this special copy here, right? And this copy is using this sprite memory variable with these parentheses around it. So this is an indirect copy, indirect indexed copy, where sprite mem is actually a 2-byte value that refers to the location in memory that we want to copy from, rather than what we talked about last time. So last time what we talked about is how you could do indexing, where you say, okay, I have an address, and then I have the X register, which might have a value of, say, 15 hex, and then when I use that in an instruction like load A with 0 and X, it's going to add these two values and load A, the accumulator register, with the value at the location 15 in memory. But there's another way that you can use these, and you can use it saying that what I really want to do is I want to say that I want to look at the address that's located at a location in memory. So it's kind of like if you've ever used pointers in C, right? You're saying you're dereferencing the pointer essentially. So you have this location in memory. In this case, it's broken up into 2 bytes, one of 00, one of 02, because we want that to refer to memory location 200. So if we use that same address here, it looks like this, right? And then we're using the Y register to index into, I'm sorry, this is not correct. Well, it's sort of correct. It's not exactly right. What we're saying is we want to look at some location. Let's say it's location 15, just as an for argument's sake. And at location 15 in memory, it's got these 2 bytes. So what it's doing is it's saying, okay, these 2 bytes refer to the memory location that I want to get the value of. So now it's going to go to this location 0200 and then offset by the Y. So if Y is 0, it will stay where it is. If Y is 1, it'll add 1. Whatever the value is, you're indexing at that location pointed to by this these values in memory, and then it's loading A with those values. So it's, again, it's, if you've ever used pointers in a language like C, it's the same concept, and that's how you do it in assembly. So what we're saying is we're loading sprite mem with the value 0200 hex so that we can write the representation of the sprites into our local copy of the sprite memory that the CPU actually has access to, right? So we're going to write it into this location here in memory and then copy it over to the PPU. and we'll talk about how we did that in a second. So if it's a bullet, it's really straightforward. It's going to store the first byte, which the first byte is, oh good, the Java update again. Thanks, that's exactly what I needed. The first byte it's going to store is the Y position on screen, so the height on the screen. It's going to increment the Y index, which should not be confused by the Y position on the screen. It's this Y index register. The next byte is 1, which is the tile. So if you look at, if we go back to the if we go back to looking at the graphics in the game, there is this section where we have the sprite graphics, and barring that the colors aren't exactly right here, we have tile 0 and tile 1, which represent different parts of the different sprites. So the bullet is tile 1, and this is just hard-coded for now. Eventually, as we get more sophisticated, we will probably... sorry, I'm moving the microphone because it got jostled a little bit when I was trying to figure out what was going on with the keyboard. We will probably get a little more sophisticated and have this mapped out somehow, but because it's so simple at the moment, we're just kind of hand coding this into the program directly. Next thing is we've got the palette here, and palette 2 refers to these palettes that we talked about last time that are loaded into memory at the startup time. So it's saying that it's going to be using that palette by setting this third byte to the palette, and there's some other attributes which we'll look at in a second. And then the final byte in the 4 bytes that represent the sprite is the X position on screen, so the left, the horizontal position. So let's take a look at this for a second, because it's worth just taking a quick look. If you go to the PPU reference here and you look at OEM sprites, you can see it's called out. Again, this is what we're talking about. Byte 0 is the Y position. Byte 1 is the tile that is being displayed, as well as the bank, because you can choose between the set of sprites that you want to display, either this set or that set. And then, this is the actual sprite that we want to show. So, let's see. So then the next byte is the palette. Like I was saying, there are some bits that are not implemented. There's the priority, whether it's in front of the background or behind the background. In this case, we're just keeping it in front of the background because we're not really doing anything where we're trying to create that depth effect at all. And then the flip horizontally and vertically, which we'll cover in a second, because the ship sprite actually uses that. Okay, so for the player sprite, we're creating 4 separate sprites, actually, because the sprites can either only be 8x8 or 8x16. Right now, I've gone with an 8x8 sprite size. Probably will want to shift that to 8x16. I'm not sure. It depends on if we're going to have a lot of bigger sprites on screen for this. For now, I kept it 8x8 because the bullets are going to fit in that more evenly, and I feel like it's probably better to use the smaller sprites for that purpose. I don't know. We'll see. And then again, we're composing the player sprite with the player ship with actually 4 separate sprites. So this is the top left sprite. This is the top right sprite. So what I've done here is I've added 8 to the X position. I'm sorry. No, this is the bottom left sprite. This is why you should why I should probably put comments here. So top left sprite, bottom left sprite. So I'm just taking the Y position, I'm adding 8 to it, and then I'm creating the next. I'm creating that sprite using the next tile in the set, which is below. You can see it's actually below. Oops, I didn't mean to do that. It's below the first tile, so we have to index across into it, and then palette's the same, and we're not touching any of the horizontal and vertical mirroring bits yet, and then the X position. So then we have where it gets a little more interesting is the Y position is now the same as what was originally set. Right, so this is actually the top right sprite, and it's going to add 8 to the X position because we are building this, like I said, out of 4 separate sprites. So we're building it like this. We have the first sprite, the second sprite, the third sprite, and then the fourth sprite, and then the ship lives in that. But what we're doing in order to achieve that effect with the ship, because you'll notice that again, it's only half the ship is we're mirroring it on the other sprites. So we're loading in this palette byte, we're loading 41, and it's because we are setting the horizontal flip bit. So we've got the palette set to 1, and then 1, 2, 4. We've got, am I looking at the right value here? Yeah, I'm looking at the right value. I'm just tired and not reading it right. So we're setting this bit here in the second half of the byte, which is the flip horizontal, right? Because 1, 2, 4, 8 in the second digit in the hex value. So same thing here. We're setting 41. It's the bottom tile from here, and we're flipping it horizontally, so it composes that full ship out of those 2 identical tiles just flipped over. So then we check the end sprite. So we're just checking to see if we've reached the end of the total number of entities, and if we have, then it doesn't bother doing anything anymore. After we're done with that, we are going to let's see, what are we doing here? We are going to, I don't remember, clear register and set palette address. Oh, this maybe is for the background. Well, let's take a look, because this will be useful for everybody if I don't remember it. So loading a 2000, so 3F into 2006. So this is why these references are so useful. So let's see, PPU registers 2006 is F17. Well, that's interesting. I don't 3F and 17. CPU writes VRAM through pair of registers. PPU writes, it loads an address into PPU address, and then it writes repeatedly to PPU to fill VRAM. Oh, okay. Right. So this is a little misleading. I know what so if you remember from last stream, it was talking about how it was doing the flickering of the ship. If you let me go back to the game, when we load it up, you can see that the cockpit here is doing that little bit of flicker. And so what it's doing is it's essentially doing a counter. Excuse me, it's doing a count on the flicker value. It's checking to see if it hit the right value, and if it didn't, it's going to skip this portion. Otherwise, it is going to increment the H swap H value, and then if it hits 23, because basically what it is I don't want it to flicker all the time at a very rapid rate. It's using sort of this convoluted set of bit mask and a counter to determine if it should do the flicker. So if it's equal to 23 hex, then it will branch. If it's not equal to that, to the skip roll. Otherwise, it will actually change the value that it's storing. And so this is the palette value that it's going to load into memory. And so if it skips this, then it doesn't roll the color over to the alternate. And then what it's doing here is it's just setting the palette address that it wants to write. So it's saying normally when you go and you write your palettes, you're generally writing a full set of palettes, palette colors. In this case, what I'm doing is I'm telling it that I want to write to the palette in pieces or at a specific location. So the 2006 is basically I'm loading the address that I want to write to into this register. I'm doing it in pieces because you have to tell it the full 16-bit address in 2 writes. So I'm telling it that I want to load this location. I want to write to that location by first writing it the 3F to 2006, then the 17 to 2006, which corresponds to, if we look at this in the emulator, what that corresponds to is specifically this location in the palette that's blinking here. And then all it's doing at the end is it's loading the value of the color from the palette that I want to swap and storing it by referencing 2007. And if you look at 2007, this is actually where you're writing the data. Now, if I kept writing, what it would do is it would continue to write to the palette address and continue to update those values, but I only do that one because I'm just trying to make that flicker. So it's a sort of a convoluted mess of things that just make that happen. That was just something I did for fun. And so then here's where we get to the DMA copy, where we're actually taking the values from the 0200 address, and then we are telling the system to perform the DMA load. And the DMA load is essentially just a fast copy. So if we go back to where is that going to be located? That's in the 4000 range, but it's a PPU function, isn't it? So why wouldn't it be there? Take a look at the registers again. Oh, yeah, here. So that one's a little weird because it's a 4000 register, but it's for the PPU. And basically what we're doing is we are telling the system. So normally when you're dealing with loading memory into the system or moving memory around, you're taking one byte and you're copying it to another location, and you just keep doing that over and over, right? The NES has a function called DMA, Direct Memory Access, where basically what you do is you say, I have some memory located in this case at 0200, and I'd like for you to copy it into the PPU, please. And what the DMA does, that's a D, not a P, the DMA will copy 255 bytes of memory, right? So from 200 to 2FF into the PPU. And if you do the math, that comes out to 64 sprites, because each sprite requires 4 bytes, and that's what we've set up here, right? And that's what we were doing when we were doing all of this work here in the beginning of the VBLANK. All right, so now we're done copying the sprites using the DMA, and we're clearing out the register. We're changing the scrolls so that we get the scrolling effect of the background, which is pretty straightforward to do. And then we are updating these 2000 registers, and we are done at that point with everything related to drawing in the VBLANK. So now I want to move all of this stuff after that out of here. I don't really want the code that's involved in checking controller buttons and stuff like that to be in the VBLANK, because frankly that has no business being here. This was just something that I had done because I was still trying to figure this out and really didn't know that that was not such a good idea. So let's see, so this is basically the end of that interrupt, and what I want to do is take all of that code and I want to move it here, he says, with no idea of whether or not that will even work at all. But that's what we're here for, to learn and see if this is going to do what we want it to do. So we have our label forever. Let's change this to game loop. And jump to game loop. So obviously I can't just start updating things in this loop if they're being referenced by the VBLANK, because what's going to happen is that it's possible that I try to update something that might be referenced by the VBLANK partially when the VBLANK interrupt occurs. I don't want that, because then we're going to get a partial update. Certainly don't want to be messing around with any graphics stuff. And I'm not touching any of the PPU registers in this code, so that's probably good as far as that goes. Now, what I do want to do is, so one thing to just point out here, I think I talked about it a little bit last stream, but I'm writing this value of 2 to the last byte in RAM, and that's being looked at by just some code that I loaded up in the emulator, so I can time how long my VBLANK is taking, specifically the portion that's actually updating the PPU. So it writes a value of 2 when it starts, and it writes a value of 1 when it's done. All right, so well, the first thing we need to do is, I'm pretty sure we want to do a push of the registers because if we are in the middle of doing something, I want this to occur after we start the timer, because I want that to count for something. So if we go back to the 6502 reference for the opcodes, pretty sure it's PHA. Let's say that pushes the accumulator. There is one that will push the entire processor. Oh, PHP, the programming language nobody wants anymore. I shouldn't say that. It's still pretty widely used. PHP. All right, so push processor status, and then when we're done, we want to pull the processor status because we are finished doing our thing here, and we want to restore it to where it was before we started processing the VBLANK. So I don't think this is going to actually work, but it's going to be interesting to see what happens now that we've moved all of that code out. I expect that it's going to be pretty broken. Yeah, and it is. It's so the ship is completely gone. Interesting. So I didn't expect that to work anyway, but I was kind of curious to see. The flicker is working. If I load up my script here for profiling, you can see that it's not bad. It's less than 1,000 frames. I mean, it's not really doing anything, obviously. It's kind of, I don't even know if it's actually scrolling properly or if that's an artifact of the fact that I'm streaming and recording at the same time. Let's see if I look at the name table viewer here. Well, it looks like it's going pretty smoothly. I wonder. Oh, you know, it's possible that it's doing it faster than it's actually able to update it on the screen, and that's why it looks like it's jumping. So here, let's do this. So I think I mean, we definitely don't want to just have this kind of running in the game loop at full speed. That's not the goal of why we separated this out. What I wanted to do is just have the game loop code processing separately from the VBLANK code, giving us some possibility of allowing for some overlap potentially, or at the very least just making sure that the VBLANK always stays as small as possible. So let's see, what do I want to do here? What I probably want to do in the game loop code is I want to so the VBLANK is going to occur. So what I probably want to do is I want to probably wait until the VBLANK processing code is done, because then I know it's safe for the engine to actually do its thing. But I want to do that at the end of the loop because I want it to start off by processing at least one frame. So do something like NMI done, or VBLANK done, maybe. Indicates that VBLANK has finished GPU processing. When value is 1. Oh, and if you recall last stream, I couldn't remember what NMI stood for. It's Non-Maskable Interrupt. All right, so let's that should be initialized by that loop in the beginning, and we're going to do the first loop through, and when we're done, it's going to jump back to game loop. But before we do that, what we want to do is we want to say compare VBLANK load a VBLANK done, compare 1 branch not equal to wait VBLANK done. And I almost feel like that might be a bad name. Just because it's not that we're waiting for the VBLANK to be done, we're waiting for our drawing code to be done. So maybe we'll call this draw complete. I like that a little bit better. I mean, it's more accurate. And hopefully will lead to less confusion in the future. All right, so wait for draw to complete. Okay, so now what should happen is nothing. I expect that it will just sit there and do nothing. Hopefully. That's what that's so the scrolling is happening, albeit oddly. Do I have the scrolling getting processed in VBLANK? Probably. Let's see. Scroll X and scroll Y are getting updated here, but where am I doing the increment? Load A, scroll, well, oh, I'm not incrementing scroll X, so I'm not going to see that anywhere. Load A, scroll X, yeah. Come on. Scrolly. Let's see, so it's doing a 2 by, load A2, store A, scroll Y, okay. Subtracting 2 from there, comparing. Okay, that's good. Load A, draw complete, compare to 1, branch if not equal to wait for draw to complete. So it should be just sitting there looping and doing nothing at this point. Why is it scrolling? So let's take a look at the hex editor to see. Alright, scroll X and scroll Y are thankfully basically right at the beginning, and you can see that scroll Y is still getting incremented by something. What I actually think I want to do, just for the sake of my own sanity and trying to debug this, I want to make the draw complete be at the beginning of the memory 0 page, just so it's easier to visually see what's going on. Alright, so rebuild that. Load that back into the emulator. Oh, that's fun. That's really cool. So now it's really broken. Sweet. Let's take a look at this. So why on earth is draw complete? I would have thought that that would be cleared out, because I'm blanking out everything there. Not setting anything. Alright, so it's not getting initialized for some reason. Let's do this. Load A, 0, store A, draw complete. Right? Just to make sure we're really initializing it. And it's still set to F. If I change it, still incrementing. Well, I've definitely broken this pretty badly already. That's cool. Let's see. So what would cause this to happen? Now, by all accounts, we can actually set a breakpoint here. I'm going to add, just for the sake of visually being able to see this a little bit better, I'm going to add a bunch of no-ops to the code. I'm going to load this back up. I'm going to go into the debugger. I'm going to look for those no-ops in my debugger, because that'll tell me where my code is a little bit more quickly than trying to figure it out based on just the code that I'm looking at. Here, all right, so don't you beep at me. There are the increments that I do, three at a clip. All right, so where are my no-ops? There's the controller code because it's using the rotates. There they are. So let's see. So it should be loading wait a minute. Load a draw complete is, yeah. Wait a minute. Why is it saying load X? Load X. Am I looking at the right place? Maybe I'm not. Do I have other no-ops in here that are... Yep. I have these no-ops that I'm using. I was using that for the same purpose when I was debugging a problem with the way that it was loading the memory there. All right, so let's restart this and then go back into the debugger and see. All right, so debugger. Let's find those no-ops again. You know, and I kind of knew that this was going to break stuff. I just wasn't sure to what extent it was going to be broken, because I couldn't foresee a scenario where just copying the content of the VBLANK and putting it into this loop where it would actually work. It's just, if it had worked, it would have been a very boring stream. And, you know, not that my technical difficulties before weren't just scintillating, but I would have been very surprised if that had worked. So it's loading A, yeah, with that value, which, yeah, I don't understand why. Oh, yes, I do. Wait, why are the entities still... That is weird. Something is getting initialized at the beginning of the memory that shouldn't. But if I I have a breakpoint here, so load A, compare it to 1, it's not equal, so now it's sitting in this loop. So if I let me remove this breakpoint, it's still incrementing that scroll register though. That is bizarre, right? Because scroll Y is, let's take a look. So scroll Y, 1, 2, 3, 4. So it's fourth byte in, 1, 2, 3, 4. So yeah, it's getting incremented, but what would be incrementing it? Because there's the initial code where it's initializing the background, and then there's process scrolling, which loads scroll Y. It removes 2, and it stores it and compares to 0, and then branch not equal. Right. So this is, it's basically looking at whether or not it needs to do the swap so that the scroll occurs smoothly across the vertically mirrored name table here. Oh, Well, see, now that's interesting too. It's doing that independently of... Well, now, that is very bizarre. Okay, so something else is actually... Load A, scroll Y, store A. So if we look at... If we go to the... Yes, 2005 should be the scroll registers. They are, and you write it twice. One for the X position, one for the Y position. Right? What on earth is causing... I mean, is it registering button presses too? Like, so if I do this, then if I press a key, or a button, I should say, with the Bluetooth turned on, so get this connected up. So if I press a button with the Bluetooth turned on, with the controller turned on and actually registered to the emulator, what I'm going to see is potentially, I mean, I shouldn't, but what's going to happen if it's actually still calling this code is that it is going to update this button, this controller byte, which is the second byte in memory. So the first byte is that FF value, which is for some reason FF, it should be 0, but ignoring that for a moment, if I go to this and I press a button on the controller, okay, it's not registering button presses, which means it's not checking that. Let me just make sure that it's not something stupid, like it's not even seeing the control pad. No, that's, of course it's not seeing the control pad. Why would that work the way it's supposed to? It's like none of the hardware wants to cooperate tonight. Alright, let's try that one more time. Let me re-add that button so that I don't go crazy wondering why that particular button doesn't work. Okay. Great. So now let's go back to the hex editor and take a look at the bytes in memory. If I press a button, it is registering the button presses. That is... Whoa, that is very weird. Okay. I feel like I am, well, I know I'm doing something wrong, but I feel like I'm missing something pretty obvious here. So compare A to value. So I'm loading A. VBLANK is running. Let's take a look at the debugger again. Let's see here. So if we get past the where are those no ops? There they are. So those are the no ops. Here's where it's pushing the processor state. So let's take a breakpoint there. So that looks good in that it's actually pushing the processor state, and then that's being called. Let's take a look at see if it's still calling this. It is. It is calling it. Now, that is strange because what it should be doing is it should be getting to the end of the code here. So what that would imply is that it almost seems like it, at some point is, well, I mean, it's just, it's obviously jumping back to the beginning of the loop, but why would that occur? I'm going to mute the PC so I stop hearing those little dings. It's jumping. So let's take a look at what it did. It compared load A with 0. Compare A. Oh, so is this happening? Is this actually really happening in parallel with the... That's the only thing I can think of, is that it's actually happening in parallel with the VBLANK, because the, well, but then that would have had data on the stack, right? Because when the VBLANK occurs, it pushes the registers on the stack and then it pops them off at the end. So let's do this. Actually, I don't want that. I want this at the jump. I want just after the push of the processor state, and then I want just at the end where it pops the processor state and does an RTI. Yeah. So there's the processor state saved. I'm going to run it again. Oh, PLP. Why did it only pop the one? Did I mess that up? PHP, push processor status, PLP, pull processor status. Why did it only... Why are there... There's the jump. There's the push processor status. Oh, wait a minute. So I'm wondering if I'm being a dummy, and it's pushing more than I think it's pushing. That's what I'm going to guess, is that it's probably pushing let's see. I mean, it shouldn't even have to guess it. Let me put a breakpoint here, and we can see what it's actually pushing. So it's so bizarre. All right, so we've got A5, F2, 81. I don't know why there's anything in the stack right now, but let's step over A5, F2, 81. It pushed 35 onto the stack. It's FB. And then it's FC after the pop. Did something mess up? Let's reset and run. Okay. Wait a minute. Why? No, I want a breakpoint before we actually push it on the stack. Okay. So the interesting thing is, you can see before we do any of this stuff, it looks right. Where is that stuff on the stack coming from? I mean, if it hasn't gone through here yet, then how can there be anything on the stack? D, E, F. So let's push these three things on. Should I be doing this here? Or is this just being weird because of the way that I have so many breakpoints set? Reset this and run. I'm confused. Because, yeah, what is this doing? 35. I'm obviously doing something wrong with this, or misunderstanding how this is supposed to work, but it's very strange that that's the behavior that I'm getting. Okay, so right off the bat there's stuff on the stack, but there shouldn't be anything on the stack right now. I'm not pushing anything. I'm just doing that PHP here to push right at the beginning of the VBLANK, which this is, right? We're doing the store, load and store. There's the jump, right? That's all that stuff there. So the PHP, how is that possible? Let's put a break right at the beginning, and we're just going to step through this whole thing because something is, I'm obviously missing something, but I just can't tell what it is. We will start here because that is where the stack has been already initialized. So we should see that whether or not it's in a good state to start out with. Okay, so it is. So it's at 1FF, which is what we want. And then we're clearing out the memory. Let's do this. I want to take a look at the hex editor. It's got some junk in here in memory, so we're clearing it out. Branch not equal. Okay, so when it's done, it should get here. Okay, good. And so you can see this is all zeroed out, which means that that initial loop worked fine, where it's clearing out the memory. Let's get to the point where we would begin the game loop. Game loop. So that's store a 2000. Okay, yeah. So store 2000, store 2001, where we're turning on the PPU to start rendering stuff. Let's see. That's one thing I'm not. Can we? Much better. I was going to say it. I'm not crazy. I know why it gives the symbolic names, but it doesn't help when you're trying to figure out what's going on and you don't remember what those actually map to versus the address, which is just literally right there. Cool. So yes, this is the end of the initialization, and then we load Y. Okay, yeah, so this is the beginning of the game loop. So I hit run. That looks reasonable. Look at the hex editor. That all looks reasonable. So all of that looks pretty good, right? Because draws complete is 0, or registers for the scroll values are 0. All of that looks like what I would expect to see. And the stack has nothing in it. So if we step over here where we're doing now the controller stuff, let's see what happens if we run to the point where we get to the no op, which is right above the loop. There, right? So if I run that, yeah, that all looks, well, no. So it's changed that. Something has changed that value. And it looks like it's the initialization potentially of, oh, I wonder I wonder if I missed copying some code for the initialization of the sprites. Yeah, that's probably what it is. And then as a result, it is clobbering that memory. Right? Because here is the game loop. Well, let's see. There's sprite mem. Is there something that was being done in the VBLANK that didn't get copied over that needs to be? Let's see. That's that. Begin populating the OEM data with memory. That's fine. That's VBLANK stuff that needs to happen there. Yeah, I think it's the initializing of the sprites. Sprite mem not set properly? It's not. It's not because it's initially set in. That's why. It's initially set in the VBLANK here, and it's not being done in the loop, and that's what's screwing us up. All right, so I want to move this out to. Realistically, we don't have to do that every time because the sprite mem location, at least at this point, isn't changing. So this can be done right before the game loop, and that location in memory with the sprite mem is essentially global. So it's not like we have to change anything to make the VBLANK code access it any differently than it already is. It's just that initialization is missing, which is why it's clobbering that memory. Like it is here, right? That F000FD, that is the sprite initialization code miswriting the data at the beginning of the 0 page because I never bothered setting a sprite mem address in memory. So okay, so that makes sense. That was a little weird, but that makes sense. So if I build that now, hopefully we'll just get one update and then it'll just, no, it's still, let's delete this and run. Still seeing background scrolling. Why? Okay, so it's still adding, it's still adding, it's still, this is my control, still registered here. It is, okay, so it's not processing. It is processing the input still. Son of a gun, why? All right, so maybe this gets down to now the pushing and the popping of the processor status that was so odd before. So if I step over this, it's just popping the one. So 34. Again, I feel like I'm just not. I feel like I'm just being dumb here. Push processor status. Yeah, I guess I assumed that this was pushing all of the registers, but oh, it's just pushing the flags. Oh, all right. So I guess in theory we probably do want to do that, but I'm just okay. Well, this will be the first of many stupid mistakes, but that's all right. All right, so PHP is pushing the processor status. What I want to do is I want to push all the other registers because we want to preserve their values as well. So there is PHA, PHP, and you can't. Well, you know, that's okay, sort of. It's not really okay. Okay. Because I really do want to push all of them, because if I'm using them. So what I'm debating here is, I was saying it was okay to push just the accumulator, but that's not actually true, because I need the X and Y to potentially be properly preserved when a VBLANK occurs, just because if I'm indexing into something and X and Y change, it's going to mess that up. So I want to push A, I want to push processor status, I want to transfer X to A, and then I want to push A, I want to transfer, is there transfer Y to, there is transfer Y to A, I want to push A. So we are pushing this in the order accumulator status, processor status X, Y. So we have to pop it in opposite order. So pushing, right? We want to now pop it or pull it, as they call it here. I want to do it in reverse order, right? So I'm going to pull A and then transfer A to Y. I want to then pull A again, transfer A to X. Pull the processor status, and then just pull A. Okay. It seems a little more reasonable now that I know what it's doing, and not just me randomly guessing at what it's doing. So yeah, I was thinking it was more like when you make a function call and you know it would. I was just thinking it was storing all the registers all at once, and I guess, you know, given that the 6502 is built in a time where you were trying to be as efficient as possible, you wouldn't have a call like that where it was needlessly potentially storing off all of the registers onto the stack, where you probably only need a couple. So all right, let's restart here. Get rid of the breakpoints. Let's run. Hey, all right. So that's more of what I was expecting to see. I was expecting to see one frame here where it just draws the background, and if we look at the hex editor, yeah, that's going to change because that's the Flickr code, and that's happening in the VBLANK. Don't recall. Oh, that I don't recall what that actually is. Is that the? I'm not sure what that is, honestly. Let's bring up also the profiling. I'm not sure that I really care what that is right now. Eventually I will when something else is broken, but all right, cool. So you can see that the cycles went up a little bit, and it's because we're adding the pushing and popping, pushing and pulling to the code here. Although, if we want to really get a real representation of what that's done to this, well, here's what I'll say. It actually doesn't need to time the popping off of here, only because at that point we're done updating the PPU. So we don't have to worry anymore about how long we're taking after that, per se. I mean, we do, but it's not as time sensitive, right? Because we've already updated the PPU to do what we want to do, and at this point we're just cleaning up. So I don't know that I want to time that. Like I might. Yeah, I'm good with not timing that. I don't think that that's really critical to what we're doing here. So, All right, let's go back to the loop now. So the game loop is waiting on this this flag essentially to be set with that it's done drawing, right? So it's done or drawing completed. Draw complete. Draw complete. Actually, that's another thing. I have been needlessly updating this, and that was because of that bug. I was trying to force it. Don't need to do that now. And okay, what's going on with my keyboard again? Weird. All right. So we have the game loop. It's going to go all the way to the bottom down here, and then we're going to say, okay, we're going to wait for draw to complete. That's the reason why it was not actually doing any updates. And then it jumps to the game. So basically what I want to do here is once the draw complete is set to 1, I'm going to reset it to 0 because we're going to need it to be 0 for the next time around if this code completes freaking filter keys, if this completes before the next VBLANK occurs, which hopefully it will. And we'll just sit and wait for it to we'll wait for it to come around the next time. But you know, if nothing else, we want to ensure of that. So we're going to set this memory here, and we're going to store it in draw complete. And then the next time it comes around, if the VBLANK hasn't finished its drawing, it will sit and wait again. All right, so now that we're done, what we want to do is, yeah, that'll work. So we can just increment draw complete because we just need it to be 1. Could have, you know, loaded 1 into A and then dropped it into draw complete and then done, you know, could have done the pulling from the stack, but seems unnecessary since all we really needed to do is increment. So okay, so now we should start getting actual animation again. Hey, all right, that's cool. Sprites are nowhere to be seen, so that's weird. Not exactly sure what happened there. Let's check the controller, see if it's registering. All right, it's registering. Interestingly, it's I do see the entities being updated. So the entity memory is here. It's these this FF section in memory. And when I press the key, when I press the A button like this, you can see that the memory is getting updated. And then it eventually goes back to FF, and that's because the bullets are eventually hitting the top of the screen and going away. So what's the deal? Am I wrong in my assessment that we don't need to re-incrementing the sprite memory at some point, and that's why it needs to be reset every time? Let's do this. Let's assume that it does need to be reset every time. And we're going to create a different one. Let's just test this thought out here. So sprite mem, and then we'll call this sprite mem VB for VBLANK. And effectively will refer to the same location in memory, but the difference will be that in the VBLANK code we will reference this one and reset it every time. I'm just wondering if I actually need to do that. seems transfer X to A, clear, add C, transfer X to A, check N sprites. What is X stored in? X load. So that's got the entity index in it. So it's checking, it's incrementing to the next entity. It's comparing X to the total entities, and if it's equal, then it goes to the part here where it's done. Otherwise, it's going to jump back to drawing the entities. But it's not incrementing a sprite memory, right? So, I'm not sure why it would be necessary for it to there aren't that many. Well, I'm getting tired. I'm gonna have to call it quits soon. I'm making stupid mistakes. I don't want to change all of them. I just want to change the ones that are here. If they were a separate file, I guess I could probably do just a search and replace, but we'll just do it the stupid brute force way here. Alright, so just to test out that it's not something like that, it's going to reset it every time we loop through. Well, I'll be damned. I dropped the controller. So it's still behaving strangely, but it's definitely closer to working than it was before. Well, I've been streaming for a while here, so I'm going to stop, and we'll pick this up next week on Monday at 9 p.m. Eastern. And if anybody watching has any questions, I have the chat open. We can take a few questions before I call it quits. I'll post a recording of this online on YouTube. I will edit out the long pauses of me futzing around with hardware because my system crapped out on me. All right, well, no, it doesn't look like there are any questions, so if you need to reach me, you can reach me on Twitter at Clarvis, same thing as the Twitch channel, and if you also want to, you can I believe you can post comments on the YouTube video of the recording. It's going to take me a little bit to get up on YouTube just because of the like I said, the weird errors that I was having with the hardware. I'm going to have to do a little bit of editing to cut all of that out and make it short as possible. And next time we'll figure out why the sprites are behaving in this sort of wonky way, but you know, at least we've separated everything out, you know, it seems like things are working more or less the way I want them to. Certainly not ideal with bullets just randomly populating here. It looks like it's just not clearing out the entity memory properly. My guess is it's probably the same problem as the VBLANK, where it's got to be reset every time, but I've got to figure out why. I'm not comfortable just making these changes and not understanding why that is, so I'll probably look at that off stream and then have a conclusion for Monday so we can just power through to the next part, which I'm hoping is going to be related to spawning enemies. I'm going to try and get some enemy sprites here and see if we can get spawning of enemies to occur with like a pattern, you know, like you would expect in any shooter. I have some ideas of how I want that to happen in a relatively compact form that we can just kind of type in by hand to start out with. I don't know that we want to start building any editor tools or anything like that for this project, but we'll see. If it starts to get cumbersome, you know, as we try and build the levels, then we may have to. So anyway, for those of you who watch, thanks for watching, and I'll see you Monday at 9 p.m. Eastern, and have a good night.